Welcome to Six Sigma Online Certifications. We are on the topic Six Sigma Fundamentals, Lean Foundation and Principles, Part 2. We'll talk about the bottleneck concept. For the bottleneck concept, let us understand first EMU, which is Equivalent Manufacturing Unit. Equivalent Manufacturing Unit is the measure of capacity of each process in terms of final product. So for example, if process 1 has capacity of 150 EMUs per hour, it means it is able to make something which will be good enough for making 150 final units. So now the first process has capacity of 150 units per hour, second is 90 units per hour, third is 110, and fourth is 85 units per hour. So what is the capacity of this plant? In a very layman's language, we can say we can average it, but it can go very grossly wrong. So we'll understand it in terms of bottleneck concept. So first process manufactures first unit. As soon as it manufactures first unit, and it gives to the second process which start manufacturing it. When the second process is manufacturing it, the first process being at a higher speed start building more units, and therefore we see inventories. And when the unit is going to third process, by the third process we see inventory start building up before the process 4 and before the process 2. That means there is capacity problem in process number 4 and process number 2. So when we see higher inventories getting built up in presence in front of process 4, it indicates process 4 is bottleneck. And this process decides the actual capacity of the plant. Rest all processing units, whatever they are making, will build up as inventory of the organization. So capacity of any plant is the capacity of the slowest processing step, which is called as bottleneck. But actually, if you see, in reality, we are not able to produce 85 units per hour. What are the reasons? The reasons are the losses. What are the losses? Breakdowns in the processes, maintenance which are planned. It may be changeovers from one product to another, or it can be tool change because of the life is over, or it may be just a startup loss in every shift. All the losses during this period, machine is not available for the production and therefore is called as availability losses. Same way, it can be minor stoppages for adjusting. It can be speed loss because we are running slow. It can be because distribution loss, that means we are not able to produce because something which is required as a resource has gone for distributing the product. Or it can be line organization loss because child material is not available. All these losses during this period, machine is available but we are not able to produce, and therefore is called as performance loss. The third type of loss is called rework, downgrade and scrap, all related to quality, is called as quality loss. The product of all these performances together is called as OEE, overall equipment effectiveness, which we will discuss in little more detail. For example, we have total calendar time, out of which production is not scheduled for a certain period of time. Rest of the time is called as operating time. In this operating time, we have 5 losses of equipment which we called availability losses. The rest of the time is called running time, and the ratio of the two is called as availability rate. B by A is availability rate. Now, during this running time, we have a rated speed and we are expecting some output from it, but because of certain losses which we called performance losses, we are not able to utilize machine and therefore we are producing less production. So the ratio of D, which is actual production, divided by expected production, is called as performance rate. Now, because of 3 quality related problems, we are making only certain amount of product which is good. So good product by actual product is called as quality rate. And all the 3 products, availability rate, performance rate and quality rate, when multiplied, gives overall equipment effectiveness, which gives overall capacity utilization plus the losses of not scheduling or not order. So now let us see it in a different perspective. Let us say process 1 has OEE of 60%, process 2 90%, process 3 80%, process 4 99%. Now if we see What is the plant capacity in reality? We see when we multiply the capacity with OEE, the actual capacity of the processes change, and we see that our bottleneck shifts from process 4 to process 2, and therefore bottlenecks is not just the capacity, is actually the reality which we see through overall equipment effectiveness, and therefore it is a very good method of measuring understanding bottleneck. Thank you very much for testing your knowledge on this video, or for Six Sigma certifications visit leandigit.com. For more updates about videos on this channel, please subscribe this channel. Thank you very much.